At the same moment, several major observatories published the same thing, empty frames. No noise, no blur, no cloudiness. Just background, as if there was no target. At first, it looks like a coincidence. The cameraman messed up the filter, the guide messed up, or the tracking failed. This usually happens when the night is busy and the line of observations is as tight as a cork, but then a number appears that shatters all calm explanations. Time, almost synchronous. The window lasts 18 minutes. Too smooth, too clean, too uniform for chaos. One telescope loses the object at exactly this interval. The second pretends the object isn't there, even though it's there before and after. The third records the orientation, exposure, and noise. Everything is usual. Only Atlas is missing. If it were a single tool, everything would be blamed on the device. If it were two sites, they would find a common factor, a software update, the same catalog, a bug in the schedule. But there are more than one, and they're in different countries. The most disturbing thing is visible in the metadata. The pointing is correct. The field shift is minimal. The stars are in place, like pins on a map, so the telescope was pointing where it should, and still empty. At this point, any talk of "you're glitching" becomes toxic, because any normal astronomy relies on independence. When independence repeatedly confirms the same flaw, it's no longer just noise. The first to notice the synchronization aren't the press services, it's the people who can't remain silent because they live by the numbers. Image processors, astrophotographers, those who tweak stacks and compare raw, unfiltered frames. They don't post screenshots for likes. It's dry, emotionless. Here's the before shot. Here's inside the window. Here's the after. The stars match, the background matches, but the subject looks like it's been cut out. At that very hour, NASA held an emergency call. Not because someone was scared, but because protocol has a simple rule. If several systems produce an anomalous result simultaneously, it's considered an event. The call starts with the banal, confirm the status of your data. And then the same old thing keeps coming. There's data. Telemetry is clear, guidance is normal, temperatures are normal. Then someone utters a phrase that makes the room feel crowded. We see the background, we don't see the target. And it's said without hysteria, but as if someone is reading a sentence they don't want to accept. At the same time, the exact opposite is happening in the public sphere. Short posts, carefully worded statements, temporary technical difficulties, minor processing delay, data will be updated. The official line is always the same, and that's even more frightening. It works for a single failure, but it doesn't work when the failure is the same across different instruments and within the same time frame. Inside the conference room, they start looking not at pictures, but at graphs. For each telescope, power supply, tracking, matrix response, error flags, drive status. And again, everything is too clear. Then someone does what they always do when the picture doesn't add up. They compare the star fields. If the stars are in place, then the problem isn't in the sky or the targeting. The problem is in what exactly is considered the target. And at this point, a strange thing emerges that will be debated for months. Within an 18-minute window, the object detection algorithms begin to return a confident no target, where they should be most confident. It looks like the system only sees the background and decides there's nothing important in the frame. But that's absurd, because in the before and after shots, everything works. But inside the window, it's as if someone has disabled the very presence of the object. One of the call participants says, check out manual searches of raw data. And then the dirty and honest part begins. People open files without automatic calibrations, without beautiful pipelines, just pixels. And there, too, it's empty. There's no weaker, no smeared, no gone out of the field. There really is no spot, no tail, no coma, nothing to cling to. It's as if the object passed through the frame, as if through water. By this point, it's clear we're not talking about a bad night, we're talking about an event, and an event has a form, a smooth window, synchronicity, a repeatable data structure. Such things don't like randomness. Someone says the following, and it sounds almost obscene even in a private channel. If it's not technique, then it's behavior. Not, we think so, not maybe, just dry logic. The second voice responds even colder. Behavior of what? And there's a pause, during which you can hear people simultaneously checking their own sanity. Because out loud, it sounds like fantasy. But these numbers aren't fantasy. Too many coincidences crammed into 18 minutes. And the worst part is that this period falls right in the zone of best visibility, where the most valuable details were expected. And then a secondary marker appears, which at first no one connects with the windows. At the same time, several amateur stations report a strange jump in brightness, and then a dip. It's as if someone flickered a spotlight and then hit it. Amateurs are the weak point of any beautiful version, because there are many of them. They are different. They don't have a unified software. No common schedule, no disciplined press services, and when they start to overlap, it's bad. NASA immediately grasps this. A second focus emerges within the team, leak control. And this isn't about a conspiracy, it's about the reality of the internet. If information isn't contained, someone else will. Meanwhile, someone suggests a simple test. Let's compare it to space platforms. If ground-based telescopes are blinded for one reason, space should see things differently. It's free of the atmosphere and free of local interference. Hubble's name sounds less like a symbol and more like a tool. It's like a last resort when things get confusing on Earth, and that's why the next detail hits especially hard. Hubble was already scheduled for that day. It had a window onto the object, not perfect but good enough to say, yes, it's there, or no, it's a phantom. And everyone is waiting for at least that anchor. But while 18 minutes of emptiness are passing on Earth, a strange sequence of flags appears in Hubble telemetry. Not a head-on collision, not a micrometeorite impact, but a neat set of signs, as if the system itself is retreating. And here's where the nerve begins, which is impossible to unsee. Because the coincidence of terrestrial blindness and cosmic caution in the same time window no longer feels like a bad day. This isn't publicly evident yet. On the surface, it all looks like the usual delays. The usual "we'll update later." But internally, people already understand that someone needs to answer the main question: why exactly 18 minutes? The answer, because it just happened that way, doesn't work. The answer, because it's the software, also doesn't work. There are too many different systems. Only the most annoying part remains. This window makes sense. What meaning could there possibly be in a window where you disappear from observation when you're at your best? Only one. You don't want to be seen at that moment. Not always. Not forever. Just during that moment when it's dangerous. And if that's true, the next question becomes even worse. What exactly could have been seen during those 18 minutes that should never have been visible under any circumstances? Some techies put it more simply. It's like scheduled camouflage, and everyone understands that the word camouflage here isn't a metaphor. It's an attempt to name a phenomenon that doesn't fit any other definition. Then the speed work begins, rechecking all the clocks, all the timestamps, all the targeting logs. Because if time floats, the window could be an illusion. But time doesn't float. The window holds. And when the window holds, one must admit, the object has made it so that several independent observations could not record it exactly when it should have been visible best. At this point, a decision emerges on the call that sounds mundane, but is actually panicked. We're shifting priority to non-standard methods. Radio, polarization, spectra, anything that doesn't resemble a standard image. Because if the picture switches off, it means you have to look somewhere that's harder to switch off, or more expensive, or more noticeable. And here, for the first time, the idea emerges that 18 minutes is a test, a reaction test. While everyone scrambles to hold on to the painting, Atlas continues on its trajectory. It doesn't slow down, doesn't explode, doesn't do anything convenient for explanation. It simply silently passes the section where we were supposed to see the most. And it's precisely this silent normality that makes everything more terrifying. Because at least our catastrophe is understandable. But careful, precise, time-limited blindness that feels like a choice. At this point, the story usually breaks down into two versions. One is reassuring. It's a system error. They'll find it later. The other is cutting to the quick. The error can't be that clever, and if you've listened this far, then you've already understood why the next few hours become a living hell for those who are forced to publicly say everything is fine, while simultaneously trying to figure out what exactly they just lost. An hour after the window, they experience the first illusion of relief. In the after footage, Atlas is back in place, as if nothing had happened, and this is precisely what begins to irritate them more than the disappearance itself, because a normal error doesn't behave like that. An error leaves behind trails, dirt, displacements, lost stars, and background level fluctuations. Here, everything looks as if someone cut out the object with a knife and carefully glued the hole with sky. One of the engineers says something they usually don't say out loud. If you're sure the frames are empty, then you trust the processing. Let's stop trusting the processing. And they start digging into the most unpleasant place, the raw data. Raw footage isn't pretty. It's ugly, streaky, riddled with image-reading artifacts, hot pixels, and cosmic rays that look like scratches. But there's an honesty to it. Nothing has been corrected yet. And then, in the raw footage, something strange appears inside the window. The background behaves too perfectly. The noise is uniform, the brightness distribution is too smooth, as if the sensor was operating in protection mode and deliberately averaging the image. This doesn't usually happen when a telescope simply looks at the sky. The sky is always slightly alive. The atmosphere breathes, the background moves, the pixels compete with each other. But here, the background looks like it's been coated with a thin varnish. Then they perform a simple, almost childish test. They take stars in a field and plot a brightness profile as if measuring with a ruler. If the system is honestly blind, the stars will suffer too. The stars were unharmed. The star profiles inside the window are the same as before and after. The focus is the same, the dot shape is the same, and the guiding is stable. This completely eliminates the camera went crazy theory. So, only one specific class of signal has disappeared, the one the system considers an object rather than a star field. And this no longer looks like a malfunction, but rather like filtering based on meaning. Some suggest doing the opposite. Instead of looking for Atlas, look for what remains after you've removed it. This is standard practice in astronomy, background subtraction, star subtraction, and all the extraneous stuff. They take frames before and after the window, carefully align them with the stars, and add them together to subtract one from the other. If there was nothing inside the window, the difference should be 0. The difference isn't 0. A faint trace appears in the difference image, like a fingerprint, which isn't visible in a normal photograph. It doesn't look like a comet, doesn't look like a tail, doesn't look like a dot. It appears as a narrow area where the background is slightly muted, as if someone has peeled a thin layer of brightness from the sky. Not blackness, not emptiness, but a careful, controlled darkening. And the most annoying thing is that the same imprint appears at another observatory, and at a third one, with a different matrix and a different telescope. The imprint isn't identical, but it falls in the same place in the field. At this point, the call to NASA changes tone. It's no longer, "we'll check later." A short phrase appears. We have a repeatable effect. This formulation triggers completely different protocols. Then someone asks a question that leaves a chill. If an object isn't directly visible but leaves an imprint on the background, then it hasn't disappeared. It means it has changed the way we see. And that thought is hard to shake. They start checking spectra and polarization because it's not just a picture. Light can be decomposed into its composition, and the wave's orientation can be checked. And if an object interferes, it must leave a signature somewhere. The archive contains narrow bands of spectral data, captured in passing. These are usually disliked because they lack beauty, but it's precisely there that a strange dip appears at the same wavelength. The hole is very thin, as if someone had bitten a tiny piece out of the light. This happens during absorption, but then the hole must be related to gases, and it must exist alongside the coma and tail. But here there's a dip, but no visible coma. It looks as if the absorption is occurring not in the surrounding cloud, but in something more compact, with a smooth geometry, almost like a filter or screen. Next, they retrieve Hubble telemetry. There's no explosion or impact. Instead, there's a series of small decisions by the system, as if it repeatedly sees the situation as potentially dangerous. The transitions resemble a cautious step back. Not panic, but rather caution, like an automated system that prefers to retreat into defense rather than take risks. And these transitions occur during almost the same window. Officially, you can call it anything you want. A cosmic ray, software, temperature, an old gyroscope. But the coincidence in timing makes any official version weaker than silence. Within the group, someone finally articulates what had been hanging in the air until then. If this is protection, then what was it protecting against? And from that moment on, the conversation ceases to be academic, because defenses in space aren't triggered by the beauty of a phenomenon. They're activated when a pattern appears in the data that resembles an attack on the system, an overload, blindness, or interference. The next step isn't done for sensationalism, but for verification. They take calibration frames, dark frames, flat fields, anything shot without a sky. If the window is due to an external signal, it can creep in there too. And it does. In some calibration frames, a barely noticeable structure appears inside the window, a fine grid that shouldn't depend on where the telescope is pointing. This looks like an induced readout pattern. This kind of grid can be caused by internal electronics, but then it would always be there. But it only appears during these 18 minutes. This makes people look at the word external completely differently. You can still argue that it's a coincidence. You can say someone updated a driver. You can blame the pipeline. But when the network timings coincide across different systems, the argument turns into self-delusion. At this point, military communications channels intervene, quietly, without any grandstanding. Because if this is affecting equipment, then it's no longer astronomy. It's a question of who can blind equipment remotely and how. And just then, almost by chance, another detail emerges, from amateur observers. Inside the window, some of them detect an extra point near the comet's trajectory, very faint but persistent. It doesn't appear in one frame or in one person. It appears in two people's eyes, in different places, on different cameras, and it's held relative to ATLAS, as if connected to it, not to the stars. If this is true, then the black window becomes clearer and more terrifying. Perhaps in these moments, what is visible is not a coma or a tail. Perhaps in these moments, a structure that should not be shown is visible. And then disappearing seems less like a gimmick and more like a very practical solution. Remove the visible, leave the background clean, let the world argue about software and clouds, and in the meantime, do what you came here to do. At the end of the call, someone utters a dry phrase that sounds worse than any shouting. We haven't lost the target. We've lost the ability to see it. These are two completely different problems. And before everyone leaves, a final question arises, one no one wants to answer. Was this window a one-off, or will it happen again? Because if it does, it means it was a tool, not a fluke. The strangest thing about the black window wasn't that it happened. The strangest thing was that it lasted just long enough for me to do one specific thing and leave. When the engineers first said 18 minutes, it sounded like a fluke. But in space, flukes rarely hold their shape. But here, the shape was ironclad. A sharp start, a clean finish, no half-tones. They opened a summary of all observations for the day. Not only large telescopes, but also networks of small observatories, amateur stations, automated surveys, anything that could keep the object in frame. The picture was uncomfortably neat. In some cases, only the core, not the entire object, was missing. In others, a faint coma with no center remained. In others, the frame was clear sky, as if ATLAS had never existed at that moment. It was at this moment that the first firm hypothesis was born. It wasn't us who lost the object. It was the object that chose what it would leave us in the data. It was as if it had decided that visibility could be controlled. Then came the question that had been long put off out of superstition. Why exactly 18 minutes? Why not 7? Why not 40? If it was a mistake, it could have lasted as long as anyone. One of the dynamic specialists lifted the flight geometry and placed observation windows on top of it. He wasn't looking for meaning, he was looking for a pattern, like one might look for a period in noise. The finality was almost mocking. The 18 minutes coincided with a short section where the object Earth-Sun line became especially convenient for accurately measuring the core's size. This was the very moment when it was possible to extract numbers from the images, not just general words. Shape, reflectivity, boundaries, structure. The most unpleasant information for a comet, and the object seemed to have erased this window. It left the tails, left the background, left the stars, but it took away the key parameter that turns disputes into evidence. At the same time, someone at NASA obtained Hubble's internal event log. Not public reports, but rather raw telemetry, where every automated action has a cause and a label. There was something there that made the room quieter. Before safe mode, there wasn't a jump, but a series of short warnings as if the system was seeing the same impact, intensifying in stages. And the most disturbing thing is that these steps don't resemble a radiation storm. They resemble something modulated. Not noise, but a signal that repeats at regular intervals. Someone mentioned out loud that this sounds like blinding. In aviation, this is the term used when a sensor detects a source that's too bright and goes into protective mode to avoid being burned out. Only here, the brightness doesn't have to be visible. It could be anything: radio, microwaves, plasma, or targeted sound. The main thing is that the automation reacts as if it were a targeted attack on the sensors. They correlated the timing of the steps with the precise position of the telescope. Hubble was pointed at these moments so that the object fell within a specific region of the matrix, almost the same sector. This coincidence also occurred at a couple of ground-based observatories. There, blank frames appeared precisely when the object moved closer to the center of the field, where algorithms typically employ enhanced correction. The logic was ugly, as if the effect had been calculated based on how we shoot, on our habits, our tools, our cleaning and alignment algorithms. Then they took the next step, almost instinctively. They decided to cheat the schedule. Not publish the schedule, not warn colleagues, not announce openings, but simply watch when they have to. It seemed like a small thing, but it was a small thing that made sense. If an object responds to geometry, it's predictable. If it responds to our actions, it's smarter than we'd like to admit. The next night, several telescopes received secret commands. Move the windows 11 minutes apart, move the aiming slightly to the side. Film not the center, but the surrounding area, as if the object wasn't of interest to them. And at that very moment, something happened that completely broke the chance. The black window returned, but it shifted along with their maneuver. Not by the hour, not by a random phase, but by their new geometry. It was again close to 18 minutes, give or take a second. It was as if the timer had started not on our schedule, but at the moment when we were almost at the right configuration. It was like a game where the opponent doesn't bother you all the time. He only bothers you when you're about to get the answer. One observatory managed to save a few frames, at the edge of the window. There, the object wasn't visible as a comet. It appeared as a thin, almost perfect line next to the nucleus, as if there was a second element nearby. This line was too straight to be a tail, and too stable to be noise. It lasted for 3 frames in a row, then disappeared when the window closed completely. Someone forwarded these frames to the general chat, and a second later the chat went silent, because any line near the comet instantly turns into the dreaded word, structure. Then came the second layer of horror. For amateurs who were keeping a continuous series, a false star would sometimes appear inside the window, a small dot, not listed in the catalog, and it would hover relative to Atlas. While such a dot would have been unbelievable on a normal night, after its alignment with large telescopes, doubts diminished. The possibility arose that it was a satellite of the object or a remote module. And then the black window began to look less like an attempt to hide. It began to look like an attempt to switch to a different mode. As if, during those 18 minutes, the subject was doing something that shouldn't be captured on camera. Then came a third detail, very quiet but deadly. Radio amateurs listening to the sky noted a strange increase in noise in a certain range at the exact moment when the telescopes went blind. Not a signal with text, not a clear transmission, but rather a sense of the background becoming denser. As if someone had turned a not a voice, but a field that obscures vision and interferes with measurement. These coincidences alone could have been dismissed as paranoia, but there were too many of them and they fit together like the parts of a single machine. By early morning, one of the managers articulated what no one wanted to say. The facility has a stealth mode for critical geometry, and it activates when we get close to a definitive answer. Then the question got even worse. If he could do this with telescopes, what else could he do with systems on Earth that operate on similar principles, with sensors, with communication channels, with radars? From that moment on, astronomy lost its composure completely, because what's scary in this story isn't the object's proximity. What's scary is that it can now choose what we see. The moment the black window repeated itself with a shift, their last convenient excuse disappeared. Error doesn't adapt to your deception. Error doesn't guess new geometry. Error happens and dies like an accident, and this behaved like a tool. Almost immediately, they did what people do when they lose faith in optics. They switched to other channels. If a subject has learned to blind the camera, then they need to look not with their eyes, but with something that can't be easily blocked with a single button. The first word to surface was radar. It's a word that people try to avoid saying in conjunction with comet during public briefings, as it automatically turns the conversation into a security issue. But inside the chat, the word was spoken without pause, and it sounded like a command. The problem was that you can't just take a radar. Passive astronomy operates in an open world. Radar operates in a world of access control, approvals, and silence. And the closer an object gets to Earth, the faster the silence becomes concrete. Someone suggested bypassing official channels and collecting indirect evidence, not the radar trace itself, but the consequences. Shifts in access windows, canceled sessions, empty schedules. Any bureaucracy leaves traces, even if it hides the content, and the traces appeared almost instantly. Several stations that usually publish observation windows in advance suddenly stopped doing so. Not for a week, not until further clarification, but precisely on the days when Atlas was at its best. Then came the second layer. Some archives began delivering data with a delay, as if they were being filtered. Not a sudden shutdown, but a gentle, "we'll upload it later." That's the most dangerous word. It looks innocent and destroys trust. They began mapping these delays, like mapping power outages after a storm. Where a window disappeared, where the feed stopped updating, where the format was suddenly changed to make it harder to compare frames. At the same time, one person did something simple, something that's often underestimated in such stories. He dug up old data on what failures in these systems look like in normal years. Error patterns, statistics, frequency. The comparison was eerie. Real glitches spread like dirt on glass, randomly, asymmetrically, without aesthetics. But here, everything looked like neatly cut out pieces, as if someone had used a knife to cut out precisely those minutes within the frame where the most important moments were. Against this backdrop, a rumor has surfaced that would previously have been dismissed as fantasy. Allegedly, in classified radar telemetry, the object was reflected not as a dust cloud, but as a compact structure with a stable signal, brightness. It sounded too good to be true, but beautiful things are precisely those people invent when they have nothing to show for it. And yet, there was a difference. The rumor came not as a retelling, but as a reaction to silence. The rumor had a form. It surfaced in different places, with the same words. Too stable, too sharp, not like a comet. These are the kinds of things engineers usually say when they are trying not to say too much but can no longer keep silent. So they decided to test not the content, but the behavior. If the military actually saw something, their systems would begin to behave differently. Backlight modes would change, additional sessions would be activated, random restrictions would appear in the sky, and then the worst part began. During those same days, radio noise levels in several regions increased in the bands typically targeted by long-range radio detection stations. It wasn't a single signal, but rather a pressure on the airwaves, as if someone were cranking up the power. It wasn't proof, but it was a coincidence that smacked of a technical solution. In the world of communications, randomness rarely takes the same form on different continents unless the source is global or moving. Next, they did what scientists usually do when they sense someone else's will. They tried to observe from the shadows. Don't announce windows. Don't write to shared databases. Don't post predictions. Film in a mode where the subject doesn't know they're being watched. And again, something mind-blowing happened. In these hidden sessions, Atlas often showed more normal-looking behavior, fewer tricks, fewer strange forms. It was as if he was pretending to be normal until you seriously tried to measure him. But as soon as the precise procedures for extracting the core's geometry from the frame were activated, a familiar scenario began. The background became perfect. The center of the field became empty, and at the edge, that same thin line occasionally flickered. It was like a security guard who doesn't bother passers-by, but instantly reacts to anyone reaching for a lock with a master key. It was too human a comparison for a cosmic body, and that's precisely why it resonated with everyone. At one point, an astrophysicist said something that made no one joke. If this is control, it's not necessarily intelligent. Automation that protects critical parameters from outside observation is sufficient. This thought sounded safer because it removed the word consciousness. But in essence, it changed nothing. An automation system capable of closing observation windows to your geometry is more frightening than any legend about a living object. Then another layer emerged, one of the satellite services that sometimes publishes indirect data on the state of the atmosphere and magnetosphere. Notice short anomalous fluctuations coinciding with the blind minutes. These weren't alarm everyone storms. These were subtle changes, as if a nearby source were interfering with the fields in a way that the Earth sensed but didn't shout about it to the world. And here the subject suddenly shifted away from telescopes, because as soon as you admit that an object can influence observation, you automatically admit that it can influence what is being observed, and therefore the environment. That same day, news began arriving from a completely different reality. An earthquake in a usually quiet area, a storm warning during a calm sea season, strangely shaped lightning as if painting across the clouds. Each of these events, taken separately, means nothing. The Earth is constantly making noise, but their timing with the Atlas approach was too convenient for fear not to be part of the conversation, and that was precisely the main pitfall. As soon as you connect space and weather, you turn the story into mysticism, and they desperately wanted to keep it on the edge, where numbers and timing still matter. So they didn't say, Atlas is causing a storm. They said something else. If the object is generating fields, we need to check whether its maneuvers are in sync with the subtle reactions of the Earth-Sun system. It sounds dry, but inside that dryness there was a scream, because if the match is confirmed, then the black window ceases to be a shield from cameras. It becomes part of the operating mode of the object near Earth. Then they began to note not events on Earth, but moments when the object changed its behavior. Jet restructuring, changes in the coma's brightness, the appearance and disappearance of a false star. Any marker that could be linked to time. And here, for the first time, a terrible connection arose. In those moments when the optical transmission was nothing, the indirect channels sometimes had too much. Radio noise was above normal. Telemetry was triggered in stages. Magnetic curves had a short break. This didn't prove an effect, but it suggested a structure. It was as if the object had activated a mode that did two things simultaneously. First, it obscured visibility. Second, it accomplished its task without regard for noise. And at the end of the day, one person formulated something that would have previously seemed like science fiction, but now sounded like a working hypothesis. He's not hiding, he's working, and we only see the side effects. From that moment on, they stopped trying to see Atlas. They started trying to catch its mode, like you catch not an airplane, but its radar activation, not a car, but its engine signal, and the worst was yet to come. Because if a mode has repeatability, then it has a cycle. And if there's a cycle, then you can predict the next launch, and set a trap. They called it a trap, though no one was smiling. Trap sounds like hunting, but this was something else. This was an attempt to prevent the event from dissolving into yet another unique failure. The gist was simple. If Atlas can block visibility under known windows, then there can be no known windows. No forecasts and shared databases, no posts with coordinates, no templates. They broke the observation into pieces, as if cutting a map into tiny squares. Each person was given only their own square and their own time. No one except the two coordinators saw the full grid. The grid wasn't about pretty pictures, it was about coincidences. If the black window was real, it would appear not in just one telescope, but in several at once, but according to different rules and different channels. They connected everything they could. optics, infrared, radio, spectra, any sensors that would be difficult to jam with a single trick, and most importantly, all this was done at staggered intervals, so there wouldn't be a single hour. The most unpleasant element of the network was the human element, the amateurs, those who couldn't be gathered into a single command, those with different cameras, different software, different habits, and that's precisely why they were useful. Amateurs didn't guarantee quality, but they did create chaos, and chaos breaks algorithms. If Atlas has an automatic suppression mode, it's designed for the discipline of large systems, not for hundreds of players around the world. The coordinators chose a night when the geometry was again best. Not because they wanted to, because judging by previous episodes, the object activated its mode precisely at such moments, as if it were part of its programming. They agreed on a strange rule beforehand. If a false star appears in the frame, no one reports it right away. Everyone records it, uploads the raw files, signs the hash, and remains silent until the signal is given. It was humiliating, but there was no other way. Any leak turns the experiment into a show, and a show gives the subject time, and if they respond to the attention, you're exposing yourself. Whispers within the team began to circulate that the false star had become too clever. Before, it had been a flash. Now it held steady, like a marker, and departed not chaotically, but on schedule. This star developed another characteristic. It manifested itself in roughly the same way in different people, but with a slight time shift, as if someone were swirling a beam through a network of observers. If it were a glare, it would be embedded within the optics. If it were a satellite, it would be shifting across the sky. But here, its position relative to the comet was maintained as if it were attached to it. They didn't call it a device. They called it a point source near a coma. Dry words to avoid slipping into fantasy. But the dryness was no longer enough. When the night began, they didn't have a single chat. There were 6 chats divided by region and another channel where the coordinators only marked Go, Available, Empty, and Stop. The first 20 minutes looked almost offensively normal. Atlas played like any other object. No empty space in the center, no blank backgrounds, no linear stripes at the edges. Then something they'd been afraid to see happened. On 3 telescopes simultaneously, the background became too smooth. Not a good sky, but as if someone had scrubbed the noise to a level that doesn't exist in reality. And at that very moment, 2 amateurs who were filming from the balcony noticed a point source near the coma. Same angle, same distance, almost the same brightness. It seemed like a mockery. Large systems go blind beautifully. Small ones see strange things. And all this in a single minute, as if the object were checking to see who exactly was looking. The coordinators kept their emotions in check. They did what they had set out to do. They compared not the image, but the raw timestamps, orientations, exposure parameters, and delays. And then a new pattern emerged. The black window was gone for exactly 18 minutes. It was broken into 3 short blocks, with the normal image returning for seconds between them. If it were a glitch, he would have fallen and not gotten up. But here it was like a mode switch. As if the system was scanning, then letting go for a moment, then closing again. The strangest thing is that the false star didn't disappear during these seconds. It remained. Moreover, in one set of frames, it became slightly elongated, like a small droplet, as if the source were not a point but a structure. This elongation was the first error that could be pinpointed, because elongation doesn't depend on interpretation. It depends on the dot profile, on the PSF, on how the light actually hit the sensor. One of the operators did what people always do when they're afraid to trust themselves. He checked the control stars around him. They were normal. They weren't stretching, weren't doubling, weren't breaking. So it's not the atmosphere, or the focus, or the shaking. If only the false star is stretching, then it's the star itself that's stretching. Or, rather, what makes it visible is stretching. The coordinators made a decision on the spot, not to discuss the meaning. Just record it. They asked everyone who could to repeat the episode with a different filter and a different duration, but within the same time frame. And again, a coincidence occurred that makes your fingers go cold. On the other filter, the elongation remained, but it rotated a few degrees as if the source had an orientation in space. It was no longer a point. It was like a small object near the coma, reflecting or radiating in such a way that its form blew through all attempts to make noise out of it. At that moment, Atlas made another move. In the frames of large systems, the coma became brighter, but the core became less easily detached. It was as if it had mixed in the light around itself to blur the boundaries and steal a dimension. And then, one of the amateurs, the most random of them all, sent raw files with a short exposure. The coma didn't have time to creep in the short exposure, and the source was standing nearby again. In his footage, the source wasn't simply elongated, it was double, as if 2 close points were clinging together but not flying apart, and this duality lasted exactly 3 frames? 3 frames, 3 seconds. That's not enough to theorize, but it's enough to prove the presence of something nearby. If it's repeatable and consistent across independent shots, they checked. No satellites were passing at that time, no known objects were found in catalogs, and there were no typical geometric highlights. And most importantly, it was the star that was experiencing the duality, not its neighboring stars. Then the coordinators uttered the word they'd been avoiding all night. Escort. Not the core and tail, but something nearby, acting independently. Something that could be part of the system. The word didn't mean ship, it meant second component. And even that term changed everything. Because a comet with a separate component was no longer just a dirty snowball, the next step of the trap was more drastic. They decided to provoke the target into repeating the attack. Not with an attack, not with a signal, not with stupidity. Simply by observing, but with abrupt changes in mode. Large telescopes usually operate smoothly. They did the opposite. They did it briefly, sharply, with different exposures, different filters, different shifts. This created attentional noise that was difficult to predict. And then, the black window flickered. It didn't disappear, but it malfunctioned in a different way. It started 2 minutes late, then ended early, as if the algorithm hadn't had time to synchronize. Information crept through this crack again. In one frame, the false star appeared closer to the coma than it should have been if it were simply held at a fixed distance. This meant the source was changing position, not against the background stars, but relative to the comet. And this was no longer a coincidence. This was the movement of a pair of objects, not matrix noise. The team grew quiet, because moving near a comet requires kinematics, and kinematics near a coma requires either fragmentation or maneuvering. Fragmentation is also scary, but it looks different. The fragments move along a trajectory. Their brightness fluctuates chaotically, and they dissolve. Here the brightness was stable, almost businesslike. The coordinators gave the final command of the night. Everyone who can perform the test will perform a series of scans on the control object immediately after Atlas. This will rule out any systemic effects and demonstrate that the anomaly is tied specifically to the control object. The control object was normal, no perfect backgrounds, no missing cores, no false positives. It was simple reality, which, compared to Atlas, looked like a mockery. By morning, they had something they hadn't had before. Not just one strange story, but a cluster of 3 independent facts. A black window with blocks, a false star with a shape, and the movement of this shape relative to the comet. And the most disturbing thing is that all of this arose precisely where the object should have been most visible. It's as if he's closing his eyes to the world, not out of fear, but because he's doing something important at that moment. Now they knew, the next launch of the mode would come, and if the mode had a cycle, the cycle could be intercepted. But the interception wouldn't be about cameras anymore. It would be about what the target does when it thinks it's unseen. By morning, they felt as if they'd caught not a rare anomaly, but part of a schedule. And the schedule apparently wasn't theirs to make. The most frightening thing about the black window wasn't that it happened. It was that it was so neatly broken into blocks like a working mechanism. 3 dips, 2 short gaps where the image returned for seconds. This doesn't look like a software crash or overheating. It looks like a mode switch. The coordinators did what's common in the aviation investigations. They stopped looking at what's visible and started looking at when and in what order. They superimposed timestamps from different telescopes on a single scale, without images, without emotion. Just the log, exposure, filter, direction, telemetry. And then, something impossible to unsee emerged. The gaps began not at the minute of the hour, but at the phase, as if the countdown was being triggered by an internal cycle. The cycle didn't match the usual rotational speed previously attributed to the core. It was shorter, dry, confident, almost service-like. It looked as if the object had a separate timer, not a timer for the jets, not a timer for the tail, a timer for the reaction to observation. They needed to understand one thing. If the cycle is stable, the next dip can be predicted, and cameras can be placed in the cracks, like traps for the shot. They took the 2 windows from previous nights where there had been oddities and added a third, older one which they had previously attributed to bad skies. The third dataset suddenly fell perfectly into the same phase when the scale was shifted by a constant amount. Too beautiful to be a coincidence. The coordinators called this a zero shift. It was as if the object had once started a program and was now following it without a hitch. And at that moment, they saw a second clue. NASA's public bulletins suddenly began moving the best visibility windows. Not by hours, by mere tens of minutes. Formally, this was explained by geometry, light pollution, and navigational safety. But the shifts were strangely beneficial. Every time the network of amateur and independent observatories got a chance to catch Atlas in the perfect position, the official schedule was thrown off. It didn't feel like a ban. It felt like a subtle regulation of attention, as if someone didn't want everyone staring at the same spot at once. This sparked a flare-up of anger within the team. But anger was a luxury. They had to work coolly, otherwise they would burn themselves out. They conducted a simple test. They took public observation windows and compared them with the black window. phase, which they calculated from their logs. The coincidence wasn't perfect, but it was too frequent. Public windows consistently fell in areas where the likelihood of failure was higher. The word coordination hung in the air again, only now it sounded less like a fantasy and more like a technical term. If someone knows the phase, they can shift their attention so that most of the large instruments fall into the gap, and then, officially, nothing is visible. But amateurs and independents who work haphazardly still occasionally encounter gaps, and that's exactly what happened every night. On the day with just a day left until December 21st, they decided to take a risk. Not to break protocol, but to complicate it to the point of absurdity. The network is divided into 3 layers. The first layer shoots continuously with short exposures, the second layer hits the filters, the third layer records spectra, and all this with different starting zeros, to make it difficult for an object to hit them all at once. If it has one cycle, it won't cover everything. The night began quietly, and that was the worst part. Calm always preceded their most unpleasant moments, like the lull before a bang. Then came the first dip. The background smoothed out beyond belief, the core dissolved into a coma, and several large systems returned frames as if there was nothing there. But now they knew the phase. They waited for the crack as one waits for a breath, and the crack came, short, sharp, almost mocking. It was in this gap that the false star first flared. It didn't just brighten, but seemed to switch on in a different mode. The flash lasted less than 2 seconds, but it was recorded simultaneously in 2 places, in people who were unaware of each other. In a short exposure, the source was almost a dot. In a longer exposure, it became not just elongated, but resembled a tiny, transversely serrated line. The operator's guts tightened, because the stroke signified orientation, and orientation signifies that the source has geometry, an asymmetrical shape. Immediately after the flash, the second block of the gap began. It was as if the object noticed someone had crawled through the crack and abruptly closed again, but the closure was uneven. At one telescope, the dip began half a second later and they managed to capture another frame. In this frame, the false star was closer to the coma than before, not against the background of stars, but relative to the comet. This was movement. Movement on such a scale over such a short period of time doesn't look like dust. It looks like a maneuver, or like a cluster of objects clinging together. Fragmentation of the nucleus could also have produced a companion, but fragments usually disappear into the flow. Their brightness fluctuates, and they dissolve into the coma. But here, the brightness was stable, almost even, and the flash was incredibly precise in timing, as if it had been activated on command. The third block of the failure turned out to be the most vile. It coincided with the moment when one of the large telescopes switched to an infrared filter. It was in the IR channel that it suddenly showed not emptiness, but a strange temperature dip around the core, as if in the center there was not a heated surface, but a cold structure. This was at odds with the usual dirty snow, which should heat up and glow differently. It looked like shielding, like a cold casing. The coordinators didn't allow themselves to say corpus. They said luminance distribution anomaly, but inside everyone heard the same thing. Later that night, they received another message from someone who wasn't formally part of the group. He sent raw footage and a short message. He filmed Atlas at the moment of failure, but somehow his camera didn't blind. Instead, his background became streaky, as if digital interference had occurred. The stripes didn't match typical artifacts. They were smooth and repeating, as if someone had applied a mask over the image. And the most disturbing thing, the stripes revealed a faint pattern, resembling a regular grid. Not a picture, but a structure, like an algorithm signature. This was no longer a comet behaving strangely. It was more like a situation where the observer gets what they're allowed to see. By morning, they had formulated a working hypothesis that could not be voiced. A TLAS has a phase-based observation suppression mode, and next to it, there is a separate component that can change position and produce flashes exactly in the cracks between the dips. If this is true, then December 21st ceases to be simply a date of rapprochement. It becomes a date when the regime can move to the next level. Because closeness isn't just about distance, it's about maximum observation density, maximum risk for those who don't want to be seen. And then a question arises that makes you want to avert your eyes. What will happen if at the most crucial hour, he decides not to hide, but on the contrary, to show something to precisely those who can record it? The following night was designated as a control night, but everyone understood that this was no longer a control night. This was an expectation. They chose the moment when the official windows were shifted again, and they did the opposite. They positioned the network so that it looked exactly where it was not recommended. And in the very first minutes, something strange happened. The black window began earlier than it should have. It was as if the object had delayed the timer. This was the first sign that he was adapting, and if he was adapting, then he wasn't just an automatic comet, so he is observing the observers. And at that moment, in one of the chats where there should have been only dry tags, someone wrote a single line, very short, without emotion. The companion separated for a second, then he returned. No one responded right away, because to respond would be to admit, and to admit would change the tone of the entire story. They simply set a mark, and continued filming as if it were an ordinary night, even though it was already clear inside that there would be no ordinary night anymore.